Hello.
Yes, sir. We are starting. Just
Okay.
Good morning all for day 4 sessions. I, Mrs. Manasi Shururkar, Assistant Professor, Maharashtra Education Society's Institute of Management and Career Courses, welcome all the participants and today's guest speaker for FDP in Artificial Intelligence for Education, hosted by IMCC in association with ATAL and AICTE. Before starting, a brief introduction about IMCC. MESS IMCC is having 37 years of standing in the field of information technology and management. It is affiliated to Savitribai Phule Pune University, recognized by the AICTE New Delhi. We have MCA, which is accredited by NBA, MBA programs. In addition, IMCC is a recognized PhD research center under the Faculty of Commerce and Management in SPPU. We do have BBA, BCA and BBA IB courses as well. The total student strength on campus is around 1,000. Session 1 for the day is on academic assessment and artificial intelligence. Artificial intelligence is inevitable nowadays. Future artificial intelligence is more about human emotions, compassion, values, and elimination of human sufferings. The use of AI is growing in different fields. We will be listening one such field in this session associated with the field of education, that is, at academic assessment and artificial intelligence. Pleasure to introduce our today's guest speaker, Dr. M. Sasikumar. Dr. M. Sasikumar sir is currently Executive Director of CDAC, Mumbai. He has been with CDAC since 1987 after completing his BTech from IIT Madras. He completed his post-graduation from Indian Institute of Science, Bangalore, and doctorate from BITS Pilani. His areas of interest are artificial intelligence and education technology. He has co authored two books. One is with Prentice Hall on parallel computing. Six students have completed their PhD under his guidance, and three are in progress. He has initiated and nurtured a number of projects in the area of AI and e learning during his career. He has over 100 publications so far. He is program committee member in a number of international conferences, member of board of studies and advisory board for select institutions. He is also an adjunct professor of education technology at IIT Bombay. He is fairly active in social media like Facebook, LinkedIn, and ResearchGate. Welcome to you, sir, and honor to have you as a guest speaker. I request you to proceed with your session. Over to you, sir. Thank you.
Thank you, Mansi. And good morning and welcome to all of you. Let me get my slides up. Okay, I hope the slides are visible. It says educational assessment and artificial intelligence.
yes, yes.
Yes.
Okay, great. So, I think assessment, I'm sure, is a challenge that most of you are facing these days, particularly in the pandemic mode. And as Manasi said, AI is also a very hot buzzword that everybody is excited about. Although there may be different, perceptions of what AI is and what it can do. So we will look at the space of assessment and also what AI can do in that space. Okay, so if you look at the overall, scenario of assessment, there are these three boxes. There is an instrument creation box where it may be a question paper, it may be a lab assignment, thing, it may be an assignment statement. So there is an instrument creation phase. And then there is the administration of that instrument. Maybe it is a test online, offline, on paper, in the lab, in the field, whatever. Right? There is an administration of it, and there is a evaluation of whatever has happened during that administration process. Then there may be some post-evaluation activities that you do, which is maybe to decide a ranking mechanism, to do filtering, you do want to screening, about feedback, whatever, all that things. So it's very open-ended depending on the different purposes. On the left side, in order to create the instrument, these are the things that usually comes in as input to it. One, what are the learning objectives of whatever you are doing to do? So if you say you are teaching a course, you want to know what is the eventual learning objective of the course, what is the student expected to be able to do at the end of the course, and your assessment or your questions are to be tailored to that. And then there is also the assessment plan. How do you plan to do the entire assessment? So is it how much of it is written test, how much of it is field work, how much of it is lab work, and so on. And also, what is the audience? So your question paper is going to be very different from, if you are teaching a primary students versus, an engineering student or a high school student or from professional audience and things like that, right? So these are three type of audience components that we usually kind of recognize that these are important in creating my assessment instrument. It is optionally, we may have a question bank which might provide the source of the different questions, and you may suitably incorporate that into the instrument creation process. Not everybody has question bank, so that's a part which is a little bit open from that point of view. So within this scenario, there are obviously, all of you who are teachers can obviously see the very different, very variety of challenges that you face in each of these blocks. So we will look at some of these and then see, okay, what do we do? What are the kind of things people are doing, and what are the things that can be done with AI and related technologies. So I'm not going to elaborate on the specific AI technologies, but maybe a little bit of inputs I'll give there, but I'm not going to spend the time on detailing the technology, but more of what role it can play in the assessment scenario. So roughly my talk is going to be the assessment use cases and challenges. So I said that we do have a lot of challenges. So what are some of those challenges that we are facing? And also, with particularly on the last 6 months to 1 year, there is a lot of talk about assessment for the reason that the traditional models are no longer working. We need to get the examination done or the evaluation done so that people don't lose 1 year. The activities can move on and things like that. So there is a changing profile of assessment that's been kind of necessitated because of the pandemic and the related ecosystem. So what can AI do? And that's what I will talk about it after that. So we'll talk about some of the use cases where AI can play a role, and maybe look at the challenges ahead in making all these things work. So, yeah, in between, I think about maybe 30 to 40 minutes or so, I will take a pause. And if you have any questions, you can meanwhile post it on the chat window. I will have a look at those questions and answer them. I'll end that by taking a break in between. Okay. So, now, if you look at the instrument itself or the administration process, this is kind of some quick snapshot of what are the options that we do have here. So, if you look at broadly, traditionally assignments are divided into formative and summative. So formative is something that happens during the class time or during the semester, and summative is the final evaluation that happens at the end. Then the evaluation may be in something that you do in the class, taking some surprise quiz or doing an in-class examination and so on. It may be something that you do in field. And but more appealingly today, we are more interested in also looking at things that can be done by taking the assessment home, because in-class option is not really available yet. And in-field has its own challenges. So for the time being, take-home is achieving far more significance than otherwise. Now, if you look at different modes of assessment, you have, I can broadly divide them into the multiple choice and its friends and other types of questions, right? So multiple choice and friends, because all of these are automatically evaluatable, at least to a large extent. So that's a class which is again being very much been of much interest these days because of the the requirement to do things online, and it'll be nice if the exam can be made in this form. So multiple choice itself has a lot of variations there. So you have the what is called multiple choice single answer, multiple choice multiple answer. You have the match the following type of questions. You have the questions where you have to fill in the value as typically a one word or a number in a sentence, and very short answer more questions like what is the capital of India, and those kind of things. Okay, so in theory, you can fold all of these as multiple choice. There is a finite set of answers that finite set of candidate answers, out of which a much smaller finite set becomes your valid answers. So, for example, if you take a short answer, you may have to consider case invariance or spelling mistakes and things like that. When you are giving the choices A B C D, then you can be far more rigid, because the options are given to the candidate and they only have to tick the correct ones. Okay, so but theoretically the possible answers, the candidate answers are enumeratable and a very small set, and therefore you can actually look at automatic evaluation of that. The remaining one is a much more open space of things. So there is usual long answer questions. Write a paragraph about something, write an essay on something, and discuss the advantages or disadvantages of something, and so on. You may also do things like a viva, so you like what happens in an interview, or when you do a post-project assessment. These are viva type of things, which is a more of oral examination. You can also ask somebody to draw a concept map. You can ask them to create a graph of some data. You can do more drawings. So this is different from the long answer for the reason that particularly in online mode, the way these things will be presented to you and what kind of automation can be possible is significantly different. So it's not. So when you're doing it on a text, it doesn't really matter whether I'm drawing a graph or a picture or writing text, because it's a human eye that's actually evaluating it. But if I am looking at online, obviously these two also make a difference. What is being done? We are still kind of struggling to build automated evaluation systems for both long answer and drawing based assessments. Then there is a big class of assessment called the lab assessment. So the practicals that you do, whether it is physics, chemistry labs, or even engineering labs, and all of these kind of activities. So how do I evaluate those kind of activities? And also projects, which is usually mandatory part of most of the degree programs and post-graduation programs. So how do you evaluate this? So all of this, if you look at, there are traditional ways of doing it. Whether they are perfect, what are the inadequacies of it is possibly arguable. But I'm sure you are familiar with all the space of all of these things as to how that is being done currently. Now, as I said, we want to look at, is it possible to do some of these online? Even in the existing way of doing things, there are challenges. There are things that we would like to improve, and that's I'm going to look at in the next couple of slides. So, one question to ask in when you are looking at technology is, what is the intended, or what is the intention or the purpose of the assessment? So if you look at what is happening currently, most of the assessment is primarily to determine a score. So the SSC student or the engineering student only want to know what is the GPA or CGPA that he gets, and or paper-wise how much marks you got. Okay, so we really have kind of lost sight of looking at what is the amount of learning that's happening, what is the area that I want to improve upon, and what are the areas which I'm very good at, and things like that. So those are things that we are kind of lost sight of in the current mode of assessment. And most of the time, we just evaluate the score, even question-wise. So we don't even look at the interplay between the different questions. So there are multiple questions in the same paper. Their answers do talk about each other, right? So they are not, the questions are not really that independent as you would like them to be. But again, we do not worry about it. Sometimes the different questions are evaluated by different people. So our focus is, how much mark to give to the answer for this question for the student. It's more of that choice, which is unfortunate, because that's ultimately not what assessments are supposed to be. Assessments are great feedback devices. That's a place where, in a traditional education system that we are used to, that's a place where the learners get their feedback. And unfortunately, because the assessments are, at discrete intervals, and usually the feedback comes too late, right? So it would be nice if, when we look at technology options, if the feedback could be made available to the learner early enough, and also if the feedback could be made actionable, something that he can use to improve his performance. So if I tell you that you are, 8 out of 10, it really doesn't convey anything to you, except that, yes, I think I'll move on to the next class the next year. Beyond that, it doesn't really tell you much about it. But if I tell you that, in this course, these topics you are very good at, these topics you are not doing too well, or there is a big gap in understanding of this concept and things like that. That's a place where you can go back and improve yourself. You can go back and teach, take extra material, read up to the material more, or do something or the other to improve your. Similarly, assessments are also a great feedback device for the teachers. And as we in e-learning people say, if 10% of the students fail, it is the student's fault, and if 90% of the students fail, it is the teacher's fault. So there is an element of feedback that's also important for the teachers. So if you look at, evaluate all of your students' paper, look at what is the spread of answering, or the spread of marking that the different students have got for a particular question. It does tell you a lot about, whether how effective it has been in communicating that question, that topic to the student, whether the course material that was provided to them was adequate, etc. So on the teacher side also, it's a great feedback device. But we do not actually spend much time on those aspects. And I feel that when you look at technology, this is what we should re-enable in the assessment process. Okay, we possibly, the scoring part, or the giving a mark, possibly will continue to be there, but we could make a lot more life into this aspect of assessment. And feedback can also improve the learning. So when you tell the student, this is what was wrong, or this is how it should have been done, he's also learning there. Now, whether at the time of examination I should use that as a kind of a teaching or learning opportunity, there are my arguments on both sides. So maybe the jury is still out there. But there is no denying that, I had done some work on, kind of question-based learning, right? So most of the time when you see the examination paper or the question paper is when you realize how much you have learned and how much you have not learned, right? When you read the text, it looks like, right, I know all this looks pretty easy. I understand all of this, right? But when I ask you a question, then you realize, oh, okay, no, that I have not understood this, I not understood. So feedback is obviously a great learning opportunity. Okay. So, in terms of the challenges, we have the volume challenge, particularly for the large-scale examinations, university examinations, competitive examinations, the boundary evaluations like 8 standard, 10 standard, 12 standard, and all of these are large-scale evaluations, and usually on a common paper, which means you would want to have a reasonably consistent evaluation across the entire population. The time required to evaluate. And as academics, we believe that if we can get a subjective questions, it would be better, because I can visualize the learner's thinking process. Whereas when you do an MCQ, I don't know how you arrived at that answer, whether it's sheerly out of luck or whether it is out of a serious thinking process. But when it is, when you write an answer, a long answer, half page, 1 page, 2 page, I can see how you are developing the argument and what is actually happening in your mind. But the penalty for it is that it is a much more expensive process to evaluate these answers, because wading through the student's writing and trying to understand what's actually going on in his mind are big challenges. Other challenge that we have with assessment is the consistency. So if you are evaluating, let's say 100 answer papers of one single question, I think there will be variations for the, even if the identical answer is presented to you in the first paper and in the 100th paper, there is very high likelihood that your scores actually will change. It changes because of various factors. Maybe it is our mood, is the number of papers, there are, the fatigue that is setting in, the kind of papers that you saw in between. So if you see, for example, a lot of very good answers, you would tend to be a little more miserly when you get another very good answer. But if you are getting a lot of very bad answers for a long time and then suddenly a good answer comes up, I think you will be a little more liberal in giving the marks, right? So these are all things that what sort of happens because we are a human evaluator and we are a human beings at the end of it. And if you employ multiple evaluators, you have even more challenges because there is no way to ensure that I think or I see the same perspective when I'm reading an answer that you would when you were reading the same answer. So these are obviously major challenges. I mean, we know they exist, and we live life as just as usual. But these are certainly challenges that is worth looking at. And it will also be good if whenever you are evaluating and the answers, and if there's whatever comments or feedback that you write on the answer sheet can actually be shared back to the candidate. But that's also, as I said, very very rarely done for multiple reasons. So when you're looking at technology, obviously we would like some of these things to be looked at. Plagiarism, I'm sure something that all of us are worried about. You copy from your friends, you copy from the net, you can copy from the textbooks. So there are various sources that we do, which actually defeats the purpose of the assessment. So what do we do? How do we catch it? And things like that is an ongoing problem. We know some ways of doing it, but the students know better ways of copying than our ability to detect them. Mismatch of assessment with learning objectives. I mean, I'm sure all of you have actually set question papers. How many times have you actually paused at the end of a paper and say, no, is this a good paper? Is this something that's actually fair to the students given what they are supposed to be doing? This is a challenge that actually is often overlooked. So I had one of my PhD students work on this problem of at least checking that if the learning objective is at let's say at analyzed level of Bloom's taxonomy, I should ensure my questions, at least there are some questions in that analyzed level of questions, right? So if you take a look at typical question papers, they are mostly at the lowest levels of Bloom's taxonomy, recall and understand, and very little that actually goes there. But if you look at the course learning objectives, you would actually have the entire things right up to create there. So there is mismatches actually fairly common, and it's something that we would like to look at whether what can we do about it. Evaluation is usually inadequate because of the time pressure, volume, etc. I talked about it. Distortion of purpose, because assessment can be effective feedback channel for all players, and which rarely happens to be so. Granularity of assessment. Ideally, like what should happen in a school, I should be actually assessing you every day or every session that I meet you, and not by conducting an examination at the end of the semester. But practical constraints apply, so we do highly discrete granularity as opposed to a continuous assessment, which would have been the ideal way to do. And also the legal defensibility of the assessment. And I think if you have been observant, even in exams like GATE, JEE, now the students are asking for their answer paper, the keys that was used to evaluate. They compute the score that they should be getting, and then they will argue with you why that score was not given to them, right? So the relatively shallow assessment that we are used to. I mean, I know when I was in the school, or I was appearing for exams, all of these were kind of like top secret. So of course, class test papers you would get, but whatever mark you got is what you got. But today there is a more questioning nature that is coming in. And if you want to build an automated system, this is also going to be very important. So if you want, you'll go and tell the system, why did you give me this much mark? And the system ought to be able to give you some explanation, right? And particularly if you were looking at re-evaluation of the paper, so I need to have some idea about how the original evaluator actually evaluated it. So these are also challenges. Some of them are, old, and I'm sure you are familiar with it. Some of them are, achieving more prominence now because of the higher transparency and related things there. So, as I said, there is also the issue that we are now switching to, there is a new normal that everybody is talking about. More online classes, more online examinations, relatively less physical contact and things like that. So this also raises more challenges because, for example, conducting a nationwide exam at a single point in time, including everybody, bringing them onto proctored environment is a very difficult problem. This is possibly true even at the university level or at the college level examinations. So you would possibly need to have multiple occurrences of the examination to allow more students to appear and things like that, right? And anytime when you have, the students split into 2 or 3 groups and you give them different papers, then immediately the challenges that my paper was harder than your paper and therefore I got less marks, and what do I do about all that? So that's a pressure on paper setting that's going to come out of this. And how do you ensure fairness and question non-repetition when you have large number of iterations of the exam? Proctoring is a major challenge. I've been a part of some of the committees who are evaluating proctoring solutions. So if I want you to take the examination sitting at your house, how do I know that there is a sanctity in that examination, that you are taking the exam, you are not taking help from any other sources? So how do I kind of ensure that the sanity of that examination, which would have happened when you come to the examination center and do, can be retained when you actually take the examination at your place? So can I do automatic proctoring or human-aided proctoring there? So this is also a major challenge. There are many companies who are actually working on this space. And other challenges, with all these things happening, there is more transparency in the process and everything is open to review. So why this question was there, why this answer is not correct, why this answer is correct, why this much mark was given. Potentially now everything is open. And this is going to make a lot of impact on the teachers and their question setting process and evaluation process. So pressure is actually going to increase, and we need to find ways of addressing them. At the same time, if you look at going online, there are a lot of benefits also, because the assessment can actually be taken anytime, anywhere. So students traveling and their geographic presence or their convenience timing, all these things can be made more flexible. What I like most about the online thing is this fine-grained data availability. And this, as I'm going to show you later, this is a great source for making your assessment more authentic, right? So when I can actually look at the way a student is appearing for the examination and how he spends that 1 hour, what all things he do, what he corrects, what he doesn't do, his facial expressions, his that whole movie of 1 hour of him taking the examination will tell me a lot more about his comfort on the subject than whatever he writes on the paper or on the online, right? So there is fine-grained data availability which can contain huge amount of relatively more authentic information than what would have happened otherwise. And also now I can look at non-traditional assessment options. For example, when we are doing the OLabs, the virtual labs for schools, we tell the teachers, you can actually perform an experiment up to half point and then ask the student now what's going to happen next, right? This is something that you could have never done when you're conducting a pen and paper examination, or even when you're doing an open examination for everyone. Similarly, there are opportunities to look at automatic evaluation and therefore feedback generation. If the machine is doing the evaluation, then you can make the feedback available almost instantaneously to the student, which is cutting out the time that you would have normally gone in evaluation there. And question banking and question generation are also interesting opportunities to look at. Okay, so this is the backdrop on which I'm going to talk about. And obviously, the AI buzzword is very much there. So we would like to look at what AI can do. But at the same time, I want to caution you that don't trust AI too much. Okay, AI is a highly error-prone domain. It is not like a standard software development process where if your requirements are cleanly articulated and your program reflects the logic in the requirement, your output is pretty much guaranteed to be correct, or you can verify it. AI, by definition, has a lot of statistical or domain-dependent aspects in it. And particularly, what most people mean today about when they say AI is the deep learning or the machine learning based AI. AI is a lot more than that. There is a lot of areas where these kind of models do not work, but they can still be brought under AI. So the challenge with the AI is that it's a highly data driven. So if your data is biased, your decisions can be biased. Okay, so it is very important that whoever does looking at AI systems, or if you are evaluating somebody's AI system, look at what has been done about model validation, result sanity check. So try it out, look at what is happening, interpret the output, and see whether that actually makes sense for you. Okay, so this is very 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 important because I mean, as you would have seen during the beginning of the COVID pandemic, the social media was full of predictive models. Everybody was taking 4 days data, 10 days data, and then building a predictive model saying, yes, I know what is going to happen tomorrow and day after. Now there are obviously these are all misleading things because giving a predictive model for something like a pandemic is a very difficult problem. So making it completely data driven, saying that if I have the data of what happened in the last 10 days, I can predict what is going to happen in the next 10 days. That's just wishful thinking, right? So creating proper models, ensuring that the right kind of data is gathered in, and also understanding the limitations of what these predictive models can do is very important when you're looking at AI. And it is far more important in assessment because you are playing with the students' life and their career, so or their future. So it is important that we don't allow unseen errors to cope up there. Along with AI, we should also give credit to the high computing power that's available, the huge amount of advances that has happened in natural language processing, computer vision, pattern recognition. These are also very big enablers when in using the technology in improving our assessment processes. As I said, AI is more than machine learning. It's knowledge representation and reasoning. That is the core of AI. We sometimes overlook it. Again, somebody has already talked about it, so I'm not going to elaborate on this. So, with that backdrop, I'm going to share with you some use cases about what are some of the challenges and how some of these are being done and what are the issues that remains there. So maybe that's a good place for me to pause for 5 minutes in case you have any questions. I will just check if you have any questions. Oh, there is no chat window on this, right?
Sir,
Oh, there is a chat, but there is nobody has any questions. So all is good. I hope everybody is listening and not yet asleep. It's early morning, so don't sleep, don't fall asleep. Okay, so use cases. I'm going to do about 5 or 6 of these one by one. So yeah. So one concern I mentioned about is question banking. This is something that we have been telling as part of the. I mean, one of my primary area of interest is educational technology. So we have been telling teachers that one of the great things that you benefit from in using technology for assessment is question banking. So in most of the LMSs, including Moodle or OpenEDX, they all provide you a nice question banking facility. And if you, whatever questions that you're going to add to your current examination, add it to the question bank and then pull it from there, you will be able to build up a very quality question bank over a period of time. And that's something worthwhile, worthwhile exercise because it saves you time in course of, maybe 1 year, 2 year, you would have enough questions in the question bank that you would possibly never have to create that many questions fresh. Secondly, because the questions in the bank, every time you find that a question was misinterpreted in the exam, you can actually go back and correct it in the question bank and make sure that the quality of the questions in the bank improves with the time. Okay. Anyway, these are general part. So my point is that it's a very useful activity for all teachers to do, but I know most of you don't do it. Okay. Now, what I would want from a question bank is also that, when was this question used last time and what was the performance on that question? Because these are useful factors for me to now decide, when I should reuse it and also to improve the quality. So if a question is for an intended audience is giving me a pretty bad performance, that it's not in, its discrimination power is very low, it's turning out to be much harder than I was expecting, then it's a feedback for me to go and improve this, right? And so once you have maybe online assessment and question banking, this cycle can actually be put in place. And further, we also want to have good indicators of the difficulty level. What are the potential target groups? What are the concepts that this question is actually testing? What are the concepts that this question depends on? How much time would typical student, an average student, take to answer this question? These are things that you would actually like to collect in the question banking system. Now, these are actually difficult for to estimate. Okay, so teachers do use your expertise or experience to come up with the numbers for all of these, but sometimes they can be quite massively off, and that's why you get performance problems in the questions. So it would be nice if there are ways to collect this information automatically, and some of the techniques when you do the test online are can actually do that. So for example, difficulty level can be estimated post an examination, and this can be used when you reuse the question later. Time estimate obviously you will get when you conduct the exam online. So we need to enable data collection at a finer granularity level, so that point that I emphasized earlier, in order for all these benefits to come. And even if you want to look at AI, we need data. We need data. We need a lot of paraphernalia around the data for these models to become effective. Okay, downloading some data from the net and running your TensorFlow or Keras on that is not going to give you reliable models for our requirements. So it is important that we need to enable data collection for those purposes and also understand what is the nature of the problem. So metadata population is very important, but it is difficult to do it manually. And this is one area where one could look at building automation there. And data from online assessment can actually help improve these things. So some of them we already have formulas from literature, so it's fairly easy to populate. Some of them are much harder, and you would need a lot more AI ecosystem to be put in place for these things to be done. But some could also be very, very error prone. For example, how do you define an average student in when you want to collect the time estimate? So if you look at the amount of time that different people have taken in attempting that question, and also time spent in re-attempting the question, how do I use this to create an average? One simple thing is I just sum up all of it and just divide. But I would actually like to look at defining average by looking at how these students have done on other questions. So there is interdependency that can be factored in to build a better estimations. And then the related question about question banking is, where do you get those questions? So people typically say that you should have something like 500 questions or 1,000 questions in a question bank on a topic, on a subject. And where do you get that kind of questions from? Maybe we should look at question generation. Okay. Now, this is also not a very new topic. In my team itself, about 20 years back, we had done some project on template-based questions, like for the general aptitude and things like that. So this brown box here, you have some sample of that. If a dash is traveling at dash kilometer per hour for dash minutes and dash kilometer per hour for dash minutes, what is its average speed? Now, all these dashes I can fill dynamically, and so every student actually will get a different version of the question. So one, it prevents copying. Second, you actually have to apply your mind and solve the problem than trying to be able to guess the answer or whatever. Okay. So some of these template questions are supported today in some of the systems, but beyond a point, this also a very difficult problem. Okay. So as I said, we didn't. We used some basic AI concepts, and when we did it in about 20 years back, it's a system called Vyasa. But when you go a little more complicated, for example, what is reasonable limits for values that I can do for V1 and V2? So if you say that a car is traveling at 1,000 kilometers per hour, it looks very unrealistic. Can V1 be negative? Can V1 be a fraction? So there are constraints that you start putting it, and then there are dependencies between these variables which will have to be brought in. So, for example, suppose the question was actually worded as, if a vehicle is traveling at V1 kilometer per hour for 21 minutes and reduced to V2 kilometer per hour for 22 minutes, now I have to ensure that V2 is less than V1, because otherwise the reduced word is not correct, right? So there are inter variable constraint that has to be brought in. There has to be domain values that has to be brought in. And if you start looking at some more examples of these kind of questions, you will realize that beyond a point, it does get much more complicated. Otherwise, you will generate absurd questions. Okay, so that's also important that, as I said, AI is data driven, and the amount of knowledge that you feed in decides the kind of quality that you're going to get in the output. So, you can actually get really absurd results also. So it is important that the model is suitably validated. Now, other challenge is, getting the correct answer to this question is relatively easy, right? So you actually know what is the formula to be used: V1 into T1 plus V2 into T2 divided by T1 plus T2, right? But how do I get the wrong answers? And if you set up multiple choice questions, the real challenge in MCQ question setting is getting good distractors, because if your distractors are a giveaway, even people without knowing anything about the question can actually take the correct answer. And I've seen on the net there are lots of guidelines on how to answer MCQs without knowing the subject, right? So because there are psychological elements that is coming in there. For example, if you have a bunch of numbers and only one number is odd and the others are even, there's a pretty high chance that must be the correct answer, right? So, or similarly, the longest answer, the longest option is usually the correct answer, because you spent extra effort on that one, the correct answer, to make sure it is an unambiguous and things like that. So, getting good distractor is actually key for ensuring the quality of multiple choice questions, and that's a place where, again, you need a lot of domain model, and it's a good candidate for AI. We have actually done some work in that area. So it's kind of feasible within some limit. There's a lot of energy that's required to make it work. Another kind of question generation is the comprehension type of questions, which also people are interested in. So given a small story or a poem, or maybe give a video or whatever. And then, like for example, a story could be as line, Shreyas took over as CMD of XYZ Limited from 2018 and still continues. Okay, so now I can ask the question, who is the CMD of XYZ, or what role does Shreyas have in XYZ Limited, and so on, right? So I'm kind of looking at whether you have actually understood the paragraph or the material that is given to you, and being able to answer the questions. Okay. Again, if you can look at, say, that, and some of these are pretty easy to do. So when you see something like somebody and took over or did, or some usual kind of verbs, ask something, something of something. So this is a pattern which you can use whenever you find this pattern. You can always ask the question, who is the dash of dash? Okay, and you would also know the answers. Again, getting the distractors good would be very, very difficult, because there may not even be enough candidates in that paragraph to provide distractors, or maybe you should make it more of a short answer question type. Okay, so automatic question generation is something that has been of interest to people for a long period of time. There are bits and pieces of work that's happening around, but there is a lot of opportunity there to build up capability there. And similarly, generating what, who, where kind of questions are relatively easy, because there are patterns which tells you where the answer is. Google actually uses that kind of things to, when you ask who is the president of, it recognizes that the who typically is a noun which sits at something, and the rest of that sentence will follow somewhere. So it can pick up the answer to who relatively easy. But if you want to do questions that are more of higher levels of Bloom's taxonomy on why and how and things like that, it's more challenging to set up, to create those kind of questions. But these are all still worthwhile explorations that can be done. And as I said, generating question is one, but guessing or getting the correct answer from the same paragraph or the same media, and also if you are using MCQ, getting the right answers or right wrong answers. The distractors, they are right, is a bigger challenge. Okay, so these are also something that's are good use cases. Now, how about the paper itself? So, how about automatically coming up with a question paper? Okay, so that's also a challenge that's worth looking at for the reason that I mentioned earlier, because particularly for the non-traditional type of examinations like competitive exams and all that, you want to create lots of this thing, and there is no other parameters to influence, right? So you would want to select your questions based on the topics and topic distribution. So usually your syllabus will tell you what are the topics to be covered and what is the weightage for each of the topics. So that certainly should be factored in when you are building the question paper. The last use date of questions, if you're referring to a question or question bank, the difficulty level, you would want a reasonable distribution of difficulty level in the question. So all questions should not be easy, all questions should not be difficult. So what level of difficulty for what topic and how does it distribute is something that you will need to give it as input. And the learning objective, which tells you that for each topic, what is the Bloom's taxonomy level that is expected by the learner. So if you are more of history kind of recall information, then you would want to ask questions at that level. If some topic is to be at a create or analyze level, then your questions have to be at that level, right? So and how do you group questions? How do you order the question? There is an element of psychology and all that. So, for example, you normally don't put the most difficult question in an exam as the first question, right? Because there is a shock value that it creates there. So you would want to kind of jatka dheere se, you want to go a little easy there. So you want to give us relatively simpler, a comfort generation question in the beginning, and put the more difficult questions in the middle or towards the end. And fairness of question that I talked about, and does your question actually do justice to all these points of that I mentioned here, right? And the challenge is more when you need to create multiple versions of questions. If people are sitting next to each other, we usually create multiple versions of the same paper by scrambling the questions and scrambling the options if it is a MCQ online as well as offline, right? So this is also a challenge because it manually creating 5 different versions of the same paper is a very difficult process and error prone, because if you get the mapping wrong in any of the answer keys, you would have serious trouble, right? So these are things that you could actually expect. But why is it difficult? The challenge is because, for example, you will have 2 questions. The second question will say, continuing the previous question, please also answer this. Now, it is important that the previous question always remains the previous question when you are reordering the questions. So the scrambling need to take into account any dependencies which are natural in these questions or even implicit in the questions, right? So all of these you would want the technology to support. Not all of it is high-end AI technology that you would want, but as I always say, don't look at AI as the that antidote which will solve all your problem. For AI to work, you need a huge amount of base material. Okay, and the human body is a good example. Your intelligence is actually sitting at 5% of your body weight, and for the heavier people, it may be even less than 5%, right? So it is that 5% which is actually controlling all the activity that's happening in your body. So, but if you don't have this 95% of the body, that 5% is useless, right? So it is important for you to look at when you say AI applications or AI system to understand the bigger ecosystem and build the enablers, build the remaining components. Like if you don't have a good pattern recognition engine or an image processing toolkit, you will do very little with image-based machine learning systems. Okay. So as I said, we did little work on fairness assessment of question bank a few years back with one of my students at IIT. So these are also interesting things. We were mildly successful in doing it, but in practice, making these things work is much more challenging, because there is a lot of input required from the teachers. For example, when you give a question, like for example, even in maths, if you say solve and you give an equation, how do I know what topic this equation deals with? Okay, now I need to know mathematics and the mathematics of that standard for me to realize that, this is a differential equation, this is an integration, this is, limit theorem, or this is that, this is etc. Whereas if you typically look at a verbal question, the words used there will possibly give me a very reasonable amount of clues as to what topics are meant, or what is the level of learning objective, Bloom's taxonomy level that is expected. Even then, there are questions that you can actually camouflage, that when you read the question, you have no idea what topic is being tested or what is the level of understanding that's expected. Okay, so they make the challenge, AI challenge, much more deeper than what would be otherwise. In the MCQ world, I mean, everybody is fascinated by it because it's easy to evaluate. But as I mentioned earlier, setting good MCQ is a difficult task, and most of the time you will find the quality of multiple choice questions is pathetically bad. And somebody who's smart enough can actually get a pretty good mark without even knowing what the subject is, right? So getting good distractors built is a big challenge. So particularly when you look at automatic question generation or validation, then these are good challenges that can happen there. Plagiarism is harder to detect because all your answers are now ABCD. So there is only, there's only 25% possibility that I'll get the answer correct. And so how do I accuse that you have copied? Whereas if you found one sentence which is identical to what your neighbor has written, there's a very high chance that you copied it, because it's very unlikely that you will write one sentence exactly the way your neighbor has written. But I can't say the same thing with MCQs, right? So very difficult to detect issues with the question also. So because when you set the question paper, you have an interpretation of that question, and accordingly you create that answer. But suppose that question had a different interpretation. Now what happens is the answers may not be there, or the answer could be possibly an unintended answer could actually become a candidate answer, for example. Right? So ambiguity is misinterpretation, omission of important detail, and you have very little options at this point. Again, if you were doing a subjective examination, it's much easier because, okay, well, if he has understood my question differently, let me read his answer, because he would have answered it differently. So I can still be considerate and give credit to the understanding. Whereas in MCQ, I have no options there. So very little freedom to adjust the evaluation if issues are detected. So again, if there are ways to kind of automatically check whether my question has a problem or we don't have a problem. So we had done this work with the GATE examination. When we finished the GATE, our team has actually been doing the entire backend of operation for the GATE exam. So post-exam, we actually do an analysis of the GATE questions against the student performance. And we are able to flag to IIT that these questions are suspect and requires a second look. And we find that at least 50% of the questions that the students are raising objections against are actually covered by this simple, top 10 analysis that we call it. Okay. So what about lab evaluation? That's also a big challenge and a challenging task in virtual mode and also in physical mode. How do you evaluate the students' lab performance? But this is the place where I want to come back to this point I talked about collecting authentic data. So in a virtual lab, I know exactly what lab problem was given to the student with what configuration, so that I can actually check whether his approach and his answers are correct or wrong. Okay, unlike what would happen in a physical lab. Okay, and also I can collect information about what all things he did online. Okay, I don't have to depend on my invigilating capability there. I know what all things he tried, which chemical he took, where he poured, what equipment, what instrument he used, and all that kind of information is also available. So the data that an online lab provides can actually be a big enabler for you to do more authentic lab assessment. So time taken at various stages, number of trials, sequence of steps can also be used for assessment, which is not possible in a real this thing. And you can also build a virtual assistant, which is typically an AI solution for to assess the evaluation. So the assistant can actually observe and maybe even kind of direct him when you're doing the examination to give him feedback on various points. Okay, so a subset of lab assessment is programming assessment. That's also something which is challenging and it's difficult. I have written articles on LinkedIn and all that about the challenges of evaluating program programming activities in the lab. Okay, so automation is certainly welcome. People have been trying. There are solutions, and Pariksha is a solution that from Sirak Mumbai we have actually built. Basically, it uses a relatively shallow evaluation model, but with a proper ecosystem, it can actually be quite effective. And we have been doing it for our courses for a long time. So, but we ideally want to look at something which can actually look at the code and check the logical correctness, the efficiency of the code, and programming style and things like that. Now, some of it is kind of doable today because you have good open parsers available, and there are AI models that you can create. But correctness is still a very difficult problem, except for toy problems. And we don't want to look at only toy problems. If we want 100-line, 200-line program to be evaluated for correctness. Okay, so there are opportunities here, and I think with the time we would expect more solutions to come up here. But currently, yes, at some level of automated evaluation systems are available, and maybe that capability can actually grow with the time. Another interesting area to look at is smart OMR. We about 10-15 years back, when we used to conduct a nationwide examination, we were using a standard OMR technology. Okay, there's optical, those papers on which you darken the ovals to get the answer. Now, the challenge for it is you need a specialized scanner. So the OMR sheets have to be physically transferred from the place of examination to a common scanning center, and then the test be scanned. Potential loss of damage to the sheet, scanning problems, all these things are there. And you need to use their prescribed OMR sheet on which you have to buy from them in order to do OMR. So we actually did, a couple of years back, we tried to, make, common man's OMR evaluation sheet. So we said we want to use a typical office scanner for scanning the sheet, and we will use a standard, A4 size, usual printing paper as for printing the patterns, the ovals and all that. So we were pretty successful in building that kind of a thing. So we are able to build a configurable answer paper. So we can actually design your own answer paper. So if you have 20 questions, you can have the first question have only 2 options, the fifth question have 5 options and 6 options. And all of that, you can decide the layout appropriately. And then just take a printout in your office printer, then you got the OMR sheets. You can go and get the examination done. The students darken the ovals and all that. And it can be scanned using your office scanner, and the scanned images can be uploaded to the website, and we will evaluate and give you the answers. Right. So this much is currently doable. It's actually working. Now we are moving further down to look at and say, because most people have a good mobile phone with a pretty decent camera today. I mean, with the 48 megapixels and all that, I think it does much better than any scanner can do. So when a student has finished the exam, can the teacher just go around and take a photograph of the answer sheets and just do an auto upload to the server? So there, if you to visualize, you do a test in the class. You give them this print sheets on which you to darken the ovals and all that. When the exam is over, you just walk around the class with your camera. Just take a pictures of all the answer sheets. By the time you are back on the podium, the results are up there. Right? This is possible today. Of course, there is a little bit of variance in terms of when you take a photograph, the paper will not be normally laid out properly. There will be bends, there will be some parts which are missing. There will be lighting, shadow effect, and all that. So, but they are solvable today with the kind of image processing technology that is existing. So that's something that we are doing. But then we said, okay, no, we can actually go one step further. If you are looking at a single oval, instead of darkening that sheet, why can't I write a character inside? So, for example, like what I've done here, I can actually write instead of just darkening those squares, I can actually write DELHI. Okay, and a single character recognition with some reasonable assumption actually can work today. So we are now actually expanding Obrick, where you can actually do, some can be darkening the ovals, some can be, you can write a short answer questions, like what is the capital of Delhi, you can actually write it in the oval space that is given to you. So name, roll number, short answers, these are all things that we can actually recognize by your decoding your handwriting. Okay. And it's single character, single vowel, so handwriting, terrors are not that bad. So these are things that actually works. Okay. And uh, yeah, so there are challenges in handwriting variations, and also for human errors and things like that. But these are workable because basically most of these are powered by the advancements in technology, including AI that is there. Because image recognition, character recognition, these are things which have grown phenomenally over the last few years. So technologically, these are not very difficult to work on today. Okay. Now, another point, I mentioned this in the beginning itself, that when I evaluate an examination paper, can I generate feedback automatically? Now, when I get a multiple choice questions, can I say why this answer is wrong? Okay, and usually most of the online systems actually allow you to put some statement along with each option, which can be displayed back to the candidate when he chooses that option. So feedback is an important aspect of assessment, and ideally, a feedback should be able to tell me what is wrong, why it is wrong, and how do I improve so that I don't repeat the error. Okay, what is the misconception that is leading me to this error? Okay, that's what the third point is. So, and manually doing all these from papers that you collect is actually very difficult. It's a very time consuming, and you can be inconsistent and all that. But with AI capabilities, it is possible to do some amount of answer analysis, even for written answers, to be able to generate things. The field of intelligent tutoring systems actually tries to do these to a very large degree of effectiveness. So you can actually watch the steps that a student is doing when he is doing, let's say, a maths problem, and identify that in this step, when you move a term from the left side to the right side, you actually did not change the sign. Okay, so these are things that is doable today. I mean, that's a field of intelligent tutoring system, which can also provide you very good feedback, and also test whether your understanding is correct. Okay, so in order to do these kind of things for MCQ, you will need to annotate the questions with what are the topics that is dependent on, what are the prerequisites in order to make to be able to attempt these questions and things like that. Okay, so there is a little more work for the teachers to do. But if I do this capability, then I can build AI models which can actually go back and tell the student, okay, the exam was all right, you got whatever x out of 10 mark, and these are the areas that you should improve. Okay, it would be great, right, to be able to go back and give them something constructive, positive to do, and you can then convert it into a visual representation. But again, this is easy said than done. So if a question is correct, you would assume that he knows all the concept that is required, that is assumed by that question. But maybe he just took a lucky draw, and he might have got it right. So how do I eliminate that he answered this question out of purely out of chance, particularly for MCQs, and even otherwise also you can possibly guess, right? So similarly, if a question is wrong, he might know everything that is required, but somewhere when he did the calculation, he might have actually got some bit wrong. So do I penalize him saying that you don't know this concept? So how do I model this ability also in the process? So how do I do the credit blame assignment? Number of questions are not large enough. And in order to eliminate these chance factors, I need to have a very large examination. If I have 200 questions, 300 questions in a test, then I can actually use ProbStat or AI to eliminate the chance component. But usually you will have only 25 questions, 30 questions. So there are challenges there. And the concept dependency. So again, building sophisticated AI models could actually address some of these problems, but those are challenges to come. Automatic evaluation for non-MCQ is something that's been people have been excited about and been trying for a long time, but this is still an open problem because there is too much variety in the answer structure. So a compare and contrast answer looks very different from right-hand properties kind of question, or it will look very different from an analyze something kind of questions, right? And While manually doing, I may look at some keywords and some phrases and accordingly give mark. But if I do an automated, I need to make sure that it is legally defensible, right? So I need to have not just the data-driven AI. I need explainable AI, which is a current hot area. But that need to come into the picture. Just keywords is not reliable, and you can also not assume that the student will write the proper grammatically correct sentences. In the exam mode, you will only get the concept. So you can't build you rely on good parsers to pull out the information there. So people have done it for kind of essay quality, English check, and all that. But for non-MCQ questions is still an open problem there. Proctoring, a lot of people have, as I said, is working on it. And today, we can do all these pretty reliably using AI. For example, with the webcam stream coming in, you can actually automatically check when I'm looking away from the screen or looking up or down or whatever. If you're talking to someone else in the room or on the phone, if someone else is present in the room, if you're referring to a book, if you're using a phone, if it's the same person which is continuing all the exam, these kind of things can actually be tested pretty reliably today with this kind of technology that we have there. And these alerts can be given to the human proctor who can actually validate what is, whether it should be asked to leave the exam, some corrective action should be taken. Okay. So here are some experiments that we did. For example, you see with this picture, the system actually comes up with all these analysis. He analyzes the head pose and whether it is turning, tilting, up, down, those movements are flagged here. The eye gaze, whether it is left, right, or up, down, that's also flagged here. The lip movement, whether it is smiling or frowning, is detected and flagged. The eyebrows, whether it is raised or furrowed, that's flagged here. So these kind of information can be dynamically collected and can be used to build a proctoring interface to systems, which is what many companies are actually doing there. But the question again is that, for example, when I get a question, I want to think. It's very natural for me to look outside and think about it. Now the system will say, no, you can't look outside. You have to be always looking onto the screen, right? So there are these are also issues. Similarly, detecting mobile phones. If I keep a mobile phone like this, most of the systems can actually detect it. They recognize the shape of it. But if I use a proper cover of the mobile, or I use a very small mobile or something that's actually in the hand, it's actually very difficult to classify it as a mobile phone, or I'm just holding my hand. And if you use a Bluetooth, for example, that's also a challenge for them to detect. So there are false positives and negatives, but there are solutions available to some level. So at least a reasonable amount of checks can be done. You can keep the video recording with you, so for a later analysis, if you want to, if there are any complaints that is flagged there. Similarly, when my video camera takes the front view of the person taking the examination, but if somebody is behind the screen, it's actually very difficult or impossible for these cameras to detect. Okay, so you can again try and collect fine-grained data. For example, my typing speed, the number of errors that I make, the facial expressions while I'm writing the examination, my eye gaze, the answer quality across questions. These can also be used to kind of authenticate whether I'm doing any malpractice during while I'm taking the examination. Okay, so here is one examination window screen from our system. So you can see that this person is actually looking straight on the screen, and the system comes back with a 97% score. And there is all these details here. That is the 22-degree turn, up down is about -2, tilt is -3, gaze is down, right? So these are things that is today possible. Okay, so I'm going to stop here. So there is a lot that can be done with technologies for assessment. And as I'm re-emphasizing, don't look at AI as just the only factor in solving this. You need a lot of ecosystem, as I said, good quality data collection, reliable, sensor devices and things like that. With that, we can build in that 5% AI on top of it, and maybe a lot of these solutions can be done. But my AI models are error prone, so be extremely careful when you are deploying these solutions in for your problems. Okay, and so it's a much in demand from everybody. So it's not a magic one, and it's not a one solution to all problems. That's my email address. If any of you want to write to me later, you're welcome to do that. Okay, so I'm going to stop here, and maybe I can take a couple of questions
Yes, sir.
before I close.
Participants, if you have any questions, do raise your hand.
And they're all good participants, like good students. Good students don't ask questions, so uh, you also don't ask questions. So anyway, you can, as I said, write to me if there are, anything. And I mean, Vaidya is a good friend in touch. So if there is anything that you want more than that, catch him and he will connect with
Oh.
me. Connect you. Okay, thank you. And nice to meet all of you online and share my thoughts on this. Thanks.
On behalf of
1 minute.
MESS
Madam?
IMCC, yes, sir. Should I
Yes,
conclude?
madam. Continue. Yes, continue.
Yeah, thank you. On behalf of MESS IMCC and all participants, we sincerely thank Sasikumar sir for accepting our invitation and delivering the talk. Thank you, sir, for sharing your treasured knowledge of AI in education system and also discussing different experimental applications of AI in academic assessments and evaluation. Surely, it will help all the academicians in near future. Thank you once again and look forward to connect with you in near future. Thank you to participants as well for their participation. We will have a group photograph for this session.